Hello students. So today we are going to learn addition of two 8-bit numbers in assembly language programming in 8051. So for that purpose I am dividing the video in two parts. In the first part we will understand whatever program is shown in the screen. Each and every line we will understand, and then we will go to the simulation part where we will run the program and see the output in the real time. So let's start the video. So in the first line you can see that this is so expected output of this program is in the location 40 hex we will get some number, then in the location 41 hex we will get another number, and in location 50 hex we will store the carry, and in location 51 hex we will store the final result. So this will be the structure of the program. So 40 and 41 will hold the input, and 50 will hold the carry, and 51 is hold the addition of the two number that will be input into the 40 and 41 hex memory location. So let's start. So in the first line you can say that the move r0 comma hash 40 hex. So this is the immediate addressing mode in 8051. It actually tells that 40 is loaded into the r0. So r0 will hold the value 40 hex, the first line. Now in the next line the register r1 will hold 50 hex. So the first two lines signifies this. In the next line, move a comma at the rate of r0. Now this actually means that whatever value, suppose we are giving the input in the 40 hex location 01 hex. So this is the input, first input of the two number. So that number will be goes into the accumulator. So that will be take the value from the source to register A. That means whatever value we are giving in the 40 hex location, that will be transferred to the accumulator. So that will be meaning of that line. Next we are moving or saving the value first number to register R5. So R5 will store the value first number value. Whatever the first number, that will be stored into the R5 register. Next, for the carry purpose, we will be storing 00 in the R4 register. So the R4 register will be store 00 hex. Next, we are incrementing R0. So previously R0 contains 40 hex. So if we are increment R0, so our new R0 will be 41 hex. So into the 41 hex location we are taking another input. Then we are moving whatever value into the R0 again into the accumulator. So in the 4041 hex location, whatever value we are giving, that will be moving into the accumulator. So in the real time, suppose in the 40 hex location we are taking the value 98 hex, and in the 41 hex location we are getting the value 99 hex. Okay, so add a comma r5. So in the first number will be stored into the r5. So r5 will store 98 hex, as you can see, and accumulator will store the value, whatever value we are giving in the 41x, that will be stored into the accumulator. Now so accumulator will be storing 99 hex, and both the number will be added, accumulator and the r5, that means 98 and the 99 hex will be added, and the final value will be stored into the accumulator. So whatever value we are getting, that will be the store into the accumulator. This will be added and final value will be stored into the accumulator. Okay, next, jump no carry. If there is no carry, then the program will be moved to here. These all lines will be skipped. but here from the value given into the input you can see there will be the carry. So the program will move into the next location, that means increment R4. So R4 previously is 0 0, now R4 will be incremented to 0 1 hex as it is incremented. So that R4 value will be moved into the B, so B will hold 0 1 hex. Next, the value of B, whatever value B holds, that means 0 1 hex, will be moving to the address specified by R1. So R1 will hold the 50 hex. So 0 1 will be moving into the 50 hex location. So that will be used for the carry storage purpose. So store the carry. You can see here written store the carry. Next, increment R1. So R1 will hold 50 hex. So your new R1 will be 51 hex, and this 51x will be holding the value of the final result. So whatever value in the accumulator, that will be goes into the 51x. So you can see if we add this two number, we are getting the value 31x. So that value will be goes into the 51x location. So and next we are saving the value at the rate of R1. So R1 will 51, so 51 will hold the final addition result. Okay, so that will be the end of the program. So ultimately we are giving the two input at the 40 and 41 hex location, and whatever the addition value, that will be stored into the 51 hex location, and the carry will be stored into the 50 hex location. Okay, now for the simulation purpose we are going to open the Keil version 5 for to run the program. So for that purpose, first go to the project, new project, give any name as you wish. I'm giving the name add 8, save it to at your favorite location, then select the microcontroller series. Here I am selecting 889C51. Okay, next go to the target, go for options, select the frequency, select the output file, create hex file. Okay, then go to file, new, paste the program, save the program as the name. Again with the extension of .asm, mandatorily after saving the program you can see the color of the program will change. As I have said, the color of the program will change. Next go to the file, save all. Next go to the source group, add existing files to the source group 1, select the program, then add. Then you can see here under the source group 1 this program has been added. Next go to project, build target. See there is 0 error and 0 warning. Next go to the debug, start. Okay, go to the memory section and giving the RAM address 40. So you can see here the RAM address 40, and I am giving the input to the 40 and 41x. So I am giving here 98 and I am giving here 99. Then I am running the program with the help of this button. So you can see this cursor will go on until the program ends. So here program ends. After pressing this there is no more movement of this. So you can see at the location 50 the carry is 01 and the location is 51, the result is 31. So our program is successfully runs. Thank you.
Hope you like my video. Please like my video and subscribe my YouTube channel.